all my cool cats and kittens. How's everybody doing? We're jumping into our new topic on Monday here. We are going to continue with polynomials, but we're switching it up a little bit and going to factoring. So this is a totally new concept, something that we haven't seen before. And essentially what we're going to try to do is undo everything we just did. Okay, we just learned how to multiply and take this and move it this direction. And now we're going to go the other way and take that result and go back the other way. That's essentially what factoring boils down to, but I'll do a better job explaining in the actual video. And we're going to spend a couple weeks working on factoring. This is a huge concept, one of the most important things as you move on to the 20 level, and it's a skill we're going to have in our back pocket. So let's jump right in. And here we are, page 323, where you're going to launch into factoring. So like I said in the intro, factoring is kind of the opposite of multiplying. We just took all these things and we multiplied them out. Well, now we're going to write it back the other way. To kind of start that off, we're actually going to multiply, and we'll think about it. So with multiplying, we did multiplying by a monomial. Then we brought in a binomial by a binomial and looked at a few of those. And we actually looked at even bigger things, but to start, we're going to look at some of these more simple ones. So to multiply these for 2x times x plus 5, I need to remember the distributive property. And I get 2x squared plus 10x. Great. So I know that this and this are the exact same thing. 2x times x plus 5 and 2x squared plus 10x. Those are the exact same polynomial. I've just written one a little bit differently. Okay. Next example, I could do FOIL, or I could do repeated distribution. Distribute the x squared plus 3x, and distribute the 1. You'd get x plus 3. And then I would combine my like terms. I get x squared plus 4x plus 3. And again, I know that that answer and my original product are the same polynomial. They represent the same exact thing. That's huge. That's the equality we're trying to maintain. Okay. And I can do the other examples. Distribute the 2x squared plus 8x, and distribute the 3 plus 3x plus 12. Combine your like terms, and we're good to go. 2x squared plus 11x plus 12. That is the exact same as the original product I started with. And finally, the bottom one, distribute the x squared plus 5x, distribute the negative 5, minus 5x, minus 25. Oh, this was that example where the middle terms make a zero pair. Plus 5x minus 5x, that's actually just 0. That goes away. So I get this. So what I'm saying is that this right here, x squared minus 25, is the same as x minus 5 times x plus 5. Okay? Well, that is huge. That understanding of multiplication is going to be huge when it comes to factoring. So what we're going to look at is, and it kind of outlines it here, the opposite process. The opposite of multiplying is called factoring. And it's how do I go from the multiplied out back to the original product. That's what we're trying to do. Well, we actually just found a couple answers. 2x squared plus 10x, that was my answer at the top. That's the same as 2x times x plus 5. So I have successfully factored that polynomial. I've written it as a product because I already knew what the product was. Same thing, x squared plus 4x plus 3. Well, that was right here. Written as a product is x plus 1 times x plus 3. There it is. And the ones I can continue, 2x squared plus 11x plus 12. That was originally 2x plus 3 times x plus 4. So I can factor this process that I just did just by knowing what the product is. And the reason I know it is because I've done the multiplication. Well, we're going to look at different ways and different strategies to do this. Okay. Oops, I think it was x minus 5x plus 5. There we go. We're going to look at different strategies to do this, but ultimately it comes down to understanding. To factor something is to say, well, what multiplies to this result? And if I'd already done the multiplication, it's easy to go back the other way. And it's not something we're going to do all at once. We're going to start by things that look like this, then like this, then like this, on and on and on. And we're going to look at all sorts of different types of factoring and all sorts of different types of products. So, well, let's keep going. Okay. The first thing we're going to look at is called common factor, or bringing out a common factor, or removing the common factor. And this is actually something we would have looked at in last unit. Okay, finding a common factor. And it goes through all these different ways using prime factorization. That's great. And all these different methods. Well, I'm going to show you just a quick process to find the common factor. If I wanted to know the common factor between 6a cubed and 9a squared b, okay, forget about the prime factorization. You don't need that. Okay, what I'm going to say is I need to look at the number and I need to look at the variables. The greatest common factor is saying, well, what is the biggest thing that I could divide by to both of these pieces? So between 6 and 9, what is the biggest number that you could multiply or divide out? Well, 3. 6 can be divided by 3 and 9 can be divided by 3. So your GCF, in terms of number, would be 3. What is the biggest thing I could divide by perfectly? And then I go to the variables. And you say, okay, well, this has an a cubed, this has an a squared. So I could perfectly divide by a squared. Because a cubed can be divided by a squared, it's just a. And a squared can be divided by a squared, it's 1. Anything divided by itself is 1. And then with the b, well, this one has a b, so I could divide by b. This one doesn't, so it's not a common factor. There you go. So when I say common factor, what I'm saying is what is the biggest thing that you could divide from these pieces? Okay, so let's try an example. 8x squared y squared and 20xy cubed, determine the GCF. It says use prime factorization. I don't think we need to use that. I look at the number 8 and 20 and I say, well, both those are divisible by 2. So maybe I think my GCF has a 2 in it. And I say, well, no, I actually think it could be bigger than that because those numbers are also divisible by 4. 8 divided by 4 is 2. That works out perfectly. 20 divided by 4 is 5. That works out perfectly. And that's the biggest number I could divide by. Now I go to my variables. X squared and x. Well, here's the tip it actually gives us just below here. Okay. When I am looking at the variable pieces, I take the lowest degree available. So this has an x squared, this has an x to the 1. My GCF would just be that lowest exponent, x to the 1. Okay, because all of them would contain at least x to the 1. Same thing with the y's. Y squared, y to the 3. The lowest one is y squared. Both pieces at least contain a y squared. This one contains a little bit more. And there you go. There's your GCF. Okay. Yeah, there's a little tip we already kind of talked about. Let's state some common factors. So I'll do 1, and then I will let you try some ahead of me. So in each case, state the greatest common factor of the following sets of monomials: 12ab and 15a squared b cubed. Well, my GCF between 12 and 15, the largest number that can divide both of those pieces would be 3. 12 is divisible by 3, 15 is divisible by b. Between a and a squared, they both at least contain an a, so I could divide by a, and b cubed, they all include a b. So identifying the common factor, what piece could all of these be divided by? That's going to be huge. Okay, b, c, and d, try those ahead of me. Something interesting to consider, and we'll go from there. So pause and go ahead of me.
1 hour later.
And we are back. I've got B and C done ahead of you. So check your answer. Make sure you got the same thing as me. And I'll do D with you guys. So for D, I'm looking for the GCF, the greatest common factor. Something that we're going to do and something to add to this. If I'm looking at the numbers, negative 40, negative 20, negative 10, I will always include the negative as part of the thing I'm going to factor out if it is there for all of them. Okay, and there's a little bit of gray area there where certain questions will require a certain thing, but as a rule, I try to factor out the negative. So 40, 20, and 10 all have a GCF of 10, but I can also divide them by that negative. So we factor out the negative, it's called, and we'll do that in later questions. Okay, in terms of a's, I've got a cubed, a squared, a squared. Well, all of them at least contain the a squared, so I could factor that out. I could divide that out. I could remove that out. And all of them contain at least a b. So there you go, negative 10 a squared b. And that's finding the GCF. Let's move on, okay, to actually factoring now. So this is called the removing the greatest common factor. This is the first type of factoring that we're going to learn, and it's also the first type of factoring that we're always going to try to do. We're going to learn like 4 or 5 different strategies for factoring. Before you start any of the other strategies, we always start by factoring out the greatest common factor. It's the first thing we look at to do, okay? And essentially, what we're going to do is divide out that common factor. Okay, so that's where it says we are taking out or dividing out a common factor. I'm not going to do the example they do for us. I'm going to jump into the ones down below. So class example 3. Complete the factoring. So this is kind of partially filled in for us already. I started with 21x plus 14y. And we are saying, what was the GCF? What was the thing that I would have removed? And then inside, I'm left with this. Well, your GCF would be between 21 and 14 would be 7. And then it's x and y. They're different variables. I can't do anything. So I think the 7 goes in that blank. And it's absolutely correct. The best part about factoring is I can always check my answer. Because if I think this is the factored version of this, I can multiply it out and check. Distribute the 7. You get 21x plus 14y. Absolutely, that's what I did. So to factor that out, what we actually did is we took 21x and we divided by 7. We divided by the GCF. That's where I get 3x. 14y, divide that by 7, you get 2y. It's like I am bringing this chunk out. I am dividing it out or taking it out. Okay, so for b, it's the same thing. 5x to the 4 plus 15x cubed plus 5x squared. And then I've got this factored out piece, and what I did is I divided out the GCF. The GCF of this original thing was, okay, well, 5, 15, and 5. The number is going to be 5. I can at least divide by 5. And then in terms of x's, I can divide by x squared. I divide this term by 5x squared, I get x squared. Divide this term by 15x cubed, you get 3x. Divide this term by 5x squared, well, 5x squared divided by itself is just 1. So the thing I factored out was the 5x squared. That's what I'm doing. That's what I'm looking to do. Okay, let's move on. Now let's kind of look the other way. Still just filling in the blanks, filling in the puzzle. Okay. I've given you the GCF. I've told you the thing that's removed. And I've even given you some of the pieces, and you're filling in the rest. Okay, so 5a squared plus 25a. There's my thing that I want to factor. There's my polynomial I want to factor. I said my GCF was 5a. So I removed 5a, I removed 5a, and you can already see the first one. 5a squared divided by 5a, you get left with an a. And then the second piece I'd have to do is the 25a divided by 5a would just equal 5. So what would go in the blank is the 5. The first one, 5a squared divided by the common factor 5a, you just get left with a. So I don't have to show that work. I'm probably doing it in my head. But the idea of factoring out a common factor is to divide that piece out. Okay? 16p minus 16q, we said the common factor was 2. So it's like I took that 18p and I divided it by 2. I factored out the 2. I did the opposite of the distributive property, the opposite of multiplication. And I would get 9p. That's what fills in the blank. The other one, 16q, I divided that by 2. Oh yeah, I would get 8q. That's the piece they have, so it works. Okay. All right, well, the next one, it only gives me the GCF, and then I have to fill in the rest myself. Negative 4mn minus 6m squared, and it says you factored out a negative 2m. Okay, negative 4nm divided by negative 2m. I'm factoring out this piece. And you probably don't have to show what I'm writing in green, but I think it's good to start. Okay, negative 4 divided by negative 2 is positive 2. M divided by m would cancel out, and you have your n. So my first term in the bracket would be 2n. Go to the next one, minus 6m squared. So negative 6m squared divided by your common factor of negative 2m. I'm dividing it out. I'm factoring it out. Equals positive 3m. M squared divided by m is just m. So plus, it would be plus 3m because it's a positive number. And there is my factored version. Negative 2m times 2n plus 3m. Okay. Try D ahead of me real quick, and I'll follow along in just a sec.
A few moments later.
And we're back, and I'll do D. So for all of these pieces, I am looking at this polynomial, and I'm factoring out a 9x. I'm saying take this divided by 9x, this divided by 9x, this divided by 9x. All of them are going to get divided by that 9x. So the first term, factor out the 9x. 18 divided by 9 is 2. X squared divided by x is x. And you'd still have your y squared. 2xy squared. Okay, next term, minus or negative 45xy. That gets divided by the 9x. Equals negative 5. X divided by x cancels out, and you got your y. So minus 5y is my next term. And the final one, 9x divided by your common factor of 9x. Oh, well, anything divided by itself is just 1. So my final term would be plus 1. Okay? And that is the idea of factoring with a common factor. You are dividing out, you are removing out, okay, the common factor. I'm undoing the multiplication. I'm bringing the multiplication back out front. Okay? Alrighty. Well, here's our final examples. And here's where we're actually going to factor. So I'll show you the whole process. Okay. 20x minus 6. What I'm saying first is, can I identify the GCF? Yeah, absolutely. The GCF would be 2. Okay. And then you say, okay, well, from both terms, if I took 20x and divided by 2, you'd have 10x. And if you took negative 6 and you divided it by 2, you'd have minus 3. That is my factored version. The equal sign is crucial here because the equal sign says, hey, 20x minus 6 is the exact same as 2 times 10x minus 3. They represent the same thing. I'm just putting it in one version compared to the other. Okay? The best thing about this, and I'll just pull up a little blank space to work, is I can always check my answer. 2 times 10x minus 3. We just spent the whole first half of this unit learning, hey, distributive property. So that is really equal to 20x minus 6. Oh yeah, that's what we started with. That's what we were trying to represent. These represent the same thing. One's just in a certain form, one's in another form. And what we're learning is how to go back and forth between the forms. Okay, here's the next one. 16x to the 4 plus 4x squared equals, well, my common factor, I can divide both of those pieces by 4, and I can divide both of those pieces by x squared. So 16x to the 4 divided by your common factor. Well, 16 divided by 4 is 4. And then the exponents, x to the 4 divided by x to the 2 is x to the 2. And then the second term, 4x squared, I factored out this 4x squared. It's like I divided by the 4x squared, I removed it out. 4x squared divided by 4x squared is just 1. And there you go. If I wanted to check, I multiply it out and I see that they are the same thing. The best part about this factoring is that I can just multiply to go the other way. All right, you have 3 more examples. This is the last opportunity to pause the video and go ahead of me.
6 months later.
And I have C done for you, so you can check your answer, and I'll finish by doing D and E. I look at D, 12p cubed minus 6p squared plus 15p. The GCF, the thing that I'm factoring out, I'm always trying to factor out the biggest possible thing. Well, 12, 6, and 15 are all divisible by 3. It has to be a number that's divisible by all of them. So maybe I would have looked and said, hey, 12 and 6, those are both divisible by 6. But it doesn't work for 15. So I need that number that's divisible, that can divide all 3 terms, which is, in this case, 3. And then they all at least contain a p. Some are p squared, p cubed, they're higher, but at least they all contain a p. Okay, I factored out. Divide by 3p. You get 4p squared. Next one, divide by 3p, you get negative 2p. 6 divided by 3 is 2, p squared divided by p is p, and plus 5. 15 divided by 3 is 5, and the p divided by p cancels out, it goes away. There's my factoring. Okay, final one. Oof, looks like a doozy. That will be all right. We'll go term by term. Find my GCF first. Between 25, 20, and 30, those are all divisible by 5. Okay, now I look at the x's. The lowest degree of x I have is just x to the 1. So they all at least contain an x to the 1. Now I'll do the y's. They all at least contain a y squared. Y squared, y squared, y to the 4 is bigger, so it could be divided by y squared. And at least a z squared. That is my lowest degree, so they all at least contain a z squared. Okay, let's go through. 25 divided by, or 25x y squared z cubed divided by my common factor. 25 divided by 5 is 5. X divided by x cancels out. Y squared divided by y squared cancels out. Z cubed divided by z squared is z. Minus 20x squared y to the 4 z squared divided by my common factor. 20 divided by 5 is 4. X squared divided by x is x. Y to the 4 divided by y to the 2 is y to the 2. And z squared divided by itself cancels out. Perfect. Plus, last one, divide everything by the common factor. 30 divided by 5 is 6. X to the 4 divided by x is x cubed. Y squared divided by y squared goes away. And wait, I did that wrong. Oh no, sorry. Y squared divided by y squared goes away. And z to the 5 divided by z squared is z cubed. Whew. That one is a doozy, but ultimately we are able to handle it. And it's just following that idea. Find the common factor, and then it's like I'm dividing all of the terms by that piece to undo the multiplication. The opposite of multiplication is to divide. And in this one, I'm undoing the multiplication that was done. I'm undoing the distributive property. Okay, and that's it. So here's some homework for you guys. Okay, page 324, 3 odd, 4 odd, 5 odd, 6 odd, 7 odd. Pretty quick questions, but crucial questions. So if you're struggling with this, send me an email, let me know. Fill out the Google form, let me know, and I'll answer. And as always, feel free to set up a one-on-one Google Meet where we can work through things together. And that is it. And that is it for our first lesson of factoring, just kind of the tip of the iceberg. We're going to work more on common factors next lesson, and then we'll move on to some variety of types. There's a lot of ways to multiply, and then there's just as many ways to kind of go back from that and factor those types of things. And that's a really big idea I want to emphasize before we leave is the factoring and the multiplying. I'm undoing the multiplication. So my result, whatever I get, I can just multiply it and I should get what I started with, right? I have the ability to check my answer. And the other thing I'll maybe point out before we move on, the reason we're doing this is to put a polynomial in a more convenient form. Sometimes the multiplied out version is more convenient. Sometimes the factored version is more convenient for what we're going to do with it after the fact. So it's a really crucial skill to be able to go back and forth between these forms. And that's why we learn factoring. And that's it. Okay, send me questions in the Google form, reach out, set up a Google Meet, all of that. Smash that like button, hit subscribe, and I will see everybody tomorrow.